Hello. In this video I'm going to work through a few more examples on how to plot the graphs of quadratic equations. Here you can see the previous example worked on in the video preceding this one, where we had y equals x squared minus 3, and I discussed how to create a basic table of values and also identify even the parabolic pattern, if you will, of our corresponding y values, and how that also relates to the graph, where you can see we have a nice healthy parabola here. Also talked briefly about how to solve quadratic equations by way of factorizing, and we found, of course, found the two real roots of this quadratic, and also discussed the minimum point, which in this case would be -3, y equals -3, and then also the equation for the line of symmetry, which was x equals 0. So I'm going to work through another one or two examples. In this video I'm just going to keep it quite introductory. In future videos I'll talk about how you can I'll talk more about how you can solve quadratic equations using factorizing. Also talk about how you can solve quadratics by completing the square, and also the importance of discriminants, how you can sketch graphs of quadratic equations and solve problems using the discriminant, which is basically derived from the quadratic formula. B squared minus 4ac will give one a sense of what roots exist for the equation, and right now we're mostly just dealing with real roots, but that also includes complex or imaginary roots. But in any case, say we are told that y equals 1/2 x squared. Yeah, 1/2 x squared. So the first step could be to just create a table, a really basic table of values. We have our x terms in the left column. We have here y equals 1/2 x squared, and we are asked to take the values of x from -4 to +4. So we'll start at -4, and so now I'm just going to plug in the x values into this equation to get the corresponding y value. So this would be 1/2 times -4 squared. -4 squared is 16. 16 times 1/2 is 16 over 2, which is going to equal 8. Now we have x equals -3. This will be 1/2 times -3 squared. -3 squared is 9, times 1/2 is 9 over 2, which is 4 and 1/2. Now we have x equals -2, which will be 1/2 times -2 squared. -2 squared is 4. 4 times 1/2 is 4 over 2, which will just leave us with 2, so y equals 2. When x equals -1, y equals 1/2 times -1 squared. -1 squared is just 1, times 1/2 is 1/2. And now we're at the origin, so when x equals 0, y equals 1/2 times 0 squared, which is just going to leave us with 0. So we've got a point on the origin in this graph, which is interesting. Now we have x equals 1, so we have 1/2 times 1 squared, which is going to give us 1/2. X equals 2, it's 1/2 times 2 squared. 2 times 2 is 4, times 1/2 is 4 over 2, which is going to be 2. And already one might begin to notice a parabolic pattern, if you will, in the in terms of the corresponding y values, where we were working from when x equals -2, y equals 2. When x equals -1, y equals 1/2. Then we found that when x equals 0, y equals 0. And then when x equals 1, y equals 1/2. And then when x equals 2, y equals 2. And so you can see a relationship forming here, a pattern forming. And so one might predict that when x equals 3, y is going to equal 4 and 1/2. Well, we'll see, because when x equals 3, y equals 1/2 times 3 squared. 3 times 3 is 9, times 1/2, that's 9 over 2, which indeed equals 4 and 1/2. And now finally, we have x equals 4. So that's 1/2 times 4 squared, which is 4 squared is 16, times 1/2, 16 over 2, which is going to equal 8. And so indeed there is certainly a pattern here, and it looks like we're going to have a fairly healthy parabola. We have no negative y values, so I'll draw the graph like this. This is the x-axis. We have 1, 2, 3, 4. Now for this side, 1, 2, 3, 4. Looks something like this. And it only goes up to 8, so 1, 2, 3, 4, 5, 6, 7, 8. Bit too much extra space here, so I'll just clean this up. And this is our y-axis. Okay, so when x equals -4, actually I should just label this quickly. 1, 2, 3, 4, 5, 6, 7, 8. So when x equals -4, y equals 8. I'll mark these points in red, like so. When x equals -3, y equals 4 and 1/2, so it's going to be right in the middle between 4 and 5. So it looks something like that. When x equals -2, y equals 2, so it's going to be like that. When x equals -1, y equals 1/2, so it's going to be right about here. Now, when x equals 0, y equals 0, so we have a point, indeed, right on the origin, like so. When x equals 1, y equals 1/2, and one can see that a very symmetrical graph is forming here, where x equals 2, y equals 2. We're just basically building up the right side. X equals 3, y equals 4 and 1/2, so again it's going to be right about there. And finally, when x equals 4, y equals 8, so we're all the way back up here. And it is, although this graph isn't the best in terms of how it was drawn, you can see that it is wonderfully symmetrical, and I'll try my best to just sketch this parabola like so, and it comes down over here. Looks something like that. Okay, so it is indeed a parabola. The line of symmetry, which I'll denote in purple, remember the line of symmetry is always halfway between the x crossing points. In this case, it's halfway between -1, x equals -1, and x equals 1, and which happens to be the y-axis, again just like the previous example. So that's the line of symmetry. Line of symmetry, and the equation for the line of symmetry, that's x equals 0. Alright, and now in terms of the roots of this graph, well, you can see I'll mark it in green. It has one real root, which is right there. It doesn't actually, this graph doesn't actually cross the x-axis at all. What's actually happening is that it just kisses it, basically, almost at a tangent. You know, it just kisses it right there at that point. And so that means that we likely have two solutions right there at 0. And we can certainly show that algebraically. If we take y equals 1/2 x squared, and we set 1/2 x squared to equals, where y equals 0, so we set it to equal 0, and you could divide by 1/2 both sides, and 0 divided by 1/2, it's just going to be 0, so you're just still left with x squared equals 0, and then you could take the square root of both sides, and you're still left with x equals 0, okay? You could say plus minus 0 if you want, but, whoops, plus minus 0 if you want, but don't really need to do that. Okay, so x equals 0. So there's our one real root right there, and in terms of the minimum point, the minimum value, again that's going to be 0, y equals 0, as you can see. And yeah, do one more example. Say for instance we're given that y equals x squared plus 3x plus 2. Yeah, that will work. X squared plus 3x plus 2. Okay, so actually let's change it up a little bit. Let's say f of x equals x squared plus 3x plus 2. Okay, so you could start by creating a table of values. However, I'm going to solve this first by factorizing. And I've already made 1 or 2 videos on how to solve quadratics using factorization. I'll make another video in the future that's a little bit more comprehensive and in depth as part of the quadratics playlist. We could also solve this by completing the square, and we could also certainly plot the graph and solve the equation by using the discriminant. But in this case, I'll just solve by factorizing. And so what we want to do is, if you remember the general form of a quadratic, so ax squared plus bx plus c. Okay, so what we want to find is ac. So in other words, that's a, that's b, and that's c. Okay, a is just 1. 1 is in front of this x squared term. It's just implicit. We don't need to write it. So a is 1. So we want to find AC. It's the first step. AC. Well, AC, A times C is just 1 times 2. So that's going to equal 2. So now we want to think what adds to, or what multiplies to 2 and adds to 3, adds to B. Okay? So, well, 1 times 2 equals 2, and 1 plus 2 equals 3. So we have our two factors, our two terms. So we can rewrite this this equation. We can rewrite it as x squared plus x, which just is our 1. Okay, it's just 1x. We need to write the 1 plus x plus 2x plus 2, and that's being set to equal 0. And now we can factor an x out of this pair of terms. We can factor a 2 out of this pair. So that leaves us with x times x plus 1. We factor out a 2. That's going to leave us with 2 times x plus 1. Now we can factor out an x plus 1. And so we are left with x plus 1 and x plus 2. And these, of course, are set to equal 0. Actually, I'll write it this way. Okay, these are set to equal 0. So x plus 1 equals 0, or x plus 2 equals 0. So now we need to solve for x. Okay, so we're going to subtract 1 from both sides. So it's going to be x equals -1. And on this in this case here, we're going to subtract 2 from both sides. So x equals -2. So these are our two solutions to this equation, our two roots, as we'll see when we plot the graph. Alright, but before we get there, let's make a table of values just so we can see how everything sort of corresponds and connects. And it's always quite interesting to do so. So here's our x, and this is f of x equals x squared plus 3x plus 2. And we are asked to take values of x from -4 to +4, so we'll start at x equals -4. And so we're just going to plug in the x values into this equation to get our values for y. So that's -4 squared plus 3 times -4 plus 2. -4 squared is 16. 3 times -4 is -12. 16 minus 12 is 4, plus 2 is 6. -3, and x equals -3. We have -3 squared plus 3 times -3 plus 2. -3 squared is 9. 3 times negative 3 is negative 9 minus, so it's going to be 9 minus 9 is 0 plus 2 is 2. Okay, now we have x equals negative 2, so it's going to be negative 2 squared plus 3 times negative 2 plus 2. Negative 2 squared is 4. 3 times negative 2 is negative 6. 4 minus 6 is negative 2, plus 2 is 0. Alright, and now we've got x equals negative 1. So it's negative 1 squared plus 3 times negative 1 plus 2. Negative 1 squared is 1. And 3 times negative 1 is negative 3. So it's 1 minus 3, which is negative 2, plus 2, and again equals 0. So that's quite an interesting result. So what happens now when x equals 0? Well, y is going. This will happen to be our y-intercept as well. So we're going to end up with 0 squared plus 3 times 0 plus 2. That's just going to be 0. 0 squared is just 0. 3 times 0, of course, is just 0. Whoops. And so we're left with 2. Y equals 2 when x is 0. So that's our y-intercept, as we'll see on the graph in a moment. Okay, so just a few more. We've got x equals 1. It's going to be y is going to equal 1 squared plus 3 times 1 plus 2. 1 squared is just 1. 3 times 1 is 3. 1 plus 3 is 4. Plus 2 is 6. And again, a parabolic pattern, we could call it, is forming as we went from 6 to 2, to 0 to 0, now 2 to 6. So our graph's going to be a little bit lopsided, one might say. We're going to see predominantly, we're going to see the right the right side of the graph more than the left, it looks like. But we'll just keep going here. So when x equals 2, 2 squared plus 3 times 2 plus 2. 2 squared is 4. 2 squared is 4. 3 times 2 is 6. That's going to be 10 plus 2 is 12. Okay, now we have x equals 3, and it's almost done, where it's going to be 3 squared, y equals 3 squared plus 3 times 3 plus 2. Well, 3 squared is 9, 3 times 3 is also 9, that's 18, plus 2 is 20, and finally x equals 4. So we're going when x equals 4, y equals 4 squared plus 3 times 4 plus 2. Well, 4 squared is 16. 3 times 4 is 12. 16 plus 12 is 28 plus 2 is 30. Okay, so here are our x values and our corresponding y values. Now we can plot the graph to make sure I have enough space, because our highest y value is 30. So we need to make sure we have no negative y values. So that will help. So I'll just draw this all the way down like this, and then I'm going to draw it right across, like so. Okay, and now it's 1, 2, 3, 4. That's our x-axis. We have 1. Whoops. Try to make it as neat as possible. 1, 2, 3, 4. Negative 3, negative 2, negative 1, and that's 1, 2, 3, 4, and it's going up to 30, so I'll do multiples of 2 for the y-axis. Hopefully it all fits. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. That's perfect. And I'll just mark these in. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. It's a little bit awkward, but it should work. Right, so when x equals negative 4, what did we find? We found that y equals 6. So I'll denote these in red, mark the points in red. When x equals negative 4, y equals 6. So it's going to be right there. It's going to be very interesting graph when x equals negative 3, y equals 2. Scroll back down, x equals negative 3, y equals 2. When x equals negative 2, y equals naught, so 0. Right there, right on the x-axis. Likewise, when x equals negative 1, y equals 0. So we have two real roots, as you can see right here, and that corresponds exactly with what we had found when we solved this equation using factorization, where we found that there's a root at x equals negative 1 and a root or a solution when x equals negative 2. And that's exactly what we've got here. Now, when x equals 0, y equals 2. And as noted earlier, that's the y-intercept, and that's indeed the case where this graph will cross the y-axis. Now, when x equals 1, y equals 6. So there's our symmetrical picture forming, except we're going to see much more of the right side of this graph due to the parameters that we are given. So when x equals 2, y equals 12, so it's going to be all the way up here. When x equals 3, y equals 20, it's going to be all the way up here. And when x equals 4, y equals 30, so all the way up, right up here. I'll try my best to draw this and to kind of connect these points. It's not the most neat, but it will have to do. It's going to look something, whoops, can do better than that, something like this. Alright, and if you were to continue and say, if you were to find the corresponding y values for when x equals negative 5 or x equals negative 6, so you're to continue to find the graph moving left along the negative x-axis here, you would find that this is going to continue to develop like so. Okay, it will be perfectly symmetric and it will look lovely. In terms of the line of symmetry, let's talk about that first. The line of symmetry is going to be halfway between x equals negative 1 and x equals negative 2. It's going to be somewhere like that. Okay, oops, it's not very straight, but it does the job fine. And the equation for the line of symmetry, the line of sim, is going to equal, so x is going to equal, looks like negative 1 and 1/2. Alright, so that's the equation for the line of symmetry. As for the roots, we've already talked about the roots. We found them here when we solved this equation using factorization. Okay, and I'll denote them here and here. Now, this graph doesn't actually cross the x-axis, it just kisses these 2 points, basically, like that. Okay, so we have 2 real roots here, and the minimum value is going to be at 0. Y is going to equal 0, right? Of course, that's the minimum value. Y equals 0. And again, we could have solved this using by completing the square, or we could have plotted this graph and solved the equation using the discriminant. But I'll save that for later videos. Yeah, so I'll end this here.